Hi everyone, thank you very much for staying tuned to my channel. In today's video I'm going to be constructing parabola using eccentricity method. There is a question here we are going to be treating together. The question says construct a parabola when the distance between focus and directrix is 40 mm. The question also said that we should draw tangent and normal at 0.60 mm from the directrix. Now, before we dive into solving this particular question, we need to know what eccentricity of a parabola is. The eccentricity of a parabola is 1. And eccentricity of a parabola is the ratio between points on a parabola and a focus to the distance between the same point and the directrix. Now let me show us something using this illustration here. Now this is a parabola. This is a parabola here which we're about to do. Now the parabola has a focus. The question says that the distance from the directrix to the focus from the question given to us is 40 mm, as you can see here. So the distance from here to the focus, directrix to the focus, is 40 mm, and the eccentricity is always the vertex of the parabola, that is the ratio between the vertex and the distance between the directrix to the vertex. So if, for example, like for this question, we are given the directrix to be 40, we are given the distance of the focus from the directrix to be 40. Okay, so 40, df here is 40, so that means vf here, if vf here is 20 and vd here is also 20, that will give us 20 divided by 20, that will give us 1. So it means that the vertex is always in between the directrix and the focus. Please take note of that because we are going to be making use of that in this construction. So let's quickly dive into the construction of this parabola. Now the first thing we do here is to draw a horizontal line this way. Okay, then we draw a vertical at any point D on the horizontal line, which will represent our directrix. So this way, draw this, okay, with thin line. Then I will drop this line down. Now we are given the distance of the focus from the directrix, okay, to be 40 mm. So very quickly I'll measure 40 from the directrix. So this is the 40, so let's call that F to represent the focus. Then I will draw a perpendicular this way. Okay, we drop the line. Let's drop the line. Okay, then we need to locate the vertex, just like I explained earlier on. Okay, the vertex will be the midpoint between the directrix and the focus. Okay, so since the distance of the focus from the directrix is 40 from the question, so the vertex will be half of that will be 20. So whatever you are given, you just divide it by 2. Okay, that will be 20. So from that part, I'm going to draw a vertical. I'm going to draw a vertical now. Okay, which is my vertex. This will be the vertex, so let's call this V. Okay, so the next thing I'm going to do now, needle on the vertex, stretch to the focus this way, or make an arc on the perpendicular line of the vertex. So let's call that point. Let's call that point E. I hope you can see this. So let's call that point E. Then the next thing I'm going to do, from point E now, I'm going to join DE, extending the line above E. So extend it upward this way. Okay, I hope you can see that. So the next thing I'm going to do here, all right, from the focus this way, pick a point, just pick a random point, not up to the vertex, so it can be of any length of your choice. So I pick this point here on the directrix, so let's give that 1, let's call that 1. Okay, so now from the focus, now place on the focus, make point, get point. Okay, let's call that this point now. So the point doesn't necessarily have to be equal. Okay, I need to tell you that doesn't necessarily have to be equal. So this point, okay, just step off like that. So like that, just go like that. You can make as many points as you so wish. So let's give this 2. We have 1 here, 2. Let's call this 3, this 4, this 5, 6. So I choose to stop at 6. You can have it up to 7 depending on you. Okay, now the next thing I will do, from each of the points there, I will draw a perpendicular or a vertical line to touch line DE. Just draw it like that to touch line DE. Then I will go to 2 now. Go to 2, draw to touch line DE like that. Then 3 next to touch line DE. 4 next. Okay, then 5. I will do that for each of the line, for each of the points. So you have this. Okay, all right, so you can see this now. So the next thing, just drop the line. Let's drop the line. The line have to be thin lines. So, and this way. Okay, so I hope you can see this now. So the next thing I'm going to do, I need to get our point now. This is the most important aspect of the construction of this parabola using eccentricity method. Now look at it very well. Okay, yeah, before we get for our point, now for where this line is touching the line DE, so I'm going to call this is 1. So let's call this 1 prime. This is the focus prime. This is 2 prime. I hope you can see that. Then this is 3 prime, 4 prime. I hope you can see that. This is 5 prime, then 6 prime. I hope you can see that now. So the next thing I'm going to do now, yes, the most important aspect now. So we pick 1 to 1 prime like this. 1 to 1 prime. I hope you can see this. Place on the focus, strike an arc on that line 1 to 1 prime, both above and below like this. I hope you can see that. So that will give us our first point. So this is the first point, like this, okay, passing through the vertex. Then same way, pick 2 to 2 prime. Okay, place on the focus, always place on the focus. You have this. Okay, so this will be my point, next point, then on 2. So you have this is the next point. I hope you can see that. Okay, then go to 3 to 3, place on the focus. You have this, so this will be my point, then 3, strike 3 below. This will be my point, next point. Now okay, now go to 4, stretch until you get to 4 prime this way, place on the focus, mark like this. So this will be my point, then like this will be my point below, like that. Okay, then next one, now go to 5 and 5 prime this way, place on the focus, mark 5 like this, both above and below. So this will be my point and this will be my point. Okay, I think we are good enough. We don't necessarily have to do 6. Okay, if we so wish to do 6 the same way, like that. Okay, so with this now, I'll just take my curve, my French curve, and I will smoothly join the points together. I will join this part now this way, and you take it out this way. The next point, join this, take it out like that. Then I connect this part this way, like this. And finally we have this part connected this way, we take it out. Okay, so this is our parabola. Okay, now don't forget the other part of the question. The other part of the question says that we should draw tangent and normal at point 60 mm from the directrix. So very quickly, to do that, from the directrix, all we need to take now, take length 60. Okay, so my 60 falls here on this line. Is coincident though, falling on these 3. Okay, it wasn't intentional, so falling on these 3. So what I need to explain here is this: wherever, oh, not on, okay, it's on 3, this is 60, so wherever it falls on, all you just need to do is to draw a vertical or perpendicular line up. So wherever the perpendicular line touches the curve or the parabola, that should be a point. Let's take note of that point. Let's call that point P. Okay, that point P. Now from that point, now my own coincidentally falls on 3, so I don't need to draw the line up again, so it falls here. So this point P. So from this point P now, we are going to draw to meet the focus. From point P, draw a line to meet the focus this way. From point P, draw a line to meet the focus, like that. Okay, I hope you can see that line. From this line now, I'm going to draw a perpendicular that is at 90 degrees. I'm using this inner side of my set square as a reference point. Let it be in alignment this way, so this way, like this. So just move it to that point of the focus. Okay, point of the focus. All right, so I'm going to draw a line this way where it touches. Take note where it touches the directional line or the directrix. So let's call this point T now. This point T. Now from this point T, draw a thick line to meet point T. That will be our tangent. Okay, so that will be the tangent. I hope you can see that now. So that is the tangent. So this will give us the tangent. This is the tangent. Now the questions also say that we should draw normal. So to draw the normal, so from this point P now to that line, just align your set square this way, align your set square this way, and draw perpendicular. So that will be the normal. Okay, align your set square. So this will be our normal. So I just need my ruler to just extend the line extend the line down this way like this. Okay, so this is the normal. Okay, so I've been able to solve this particular question now. Thank you very much for staying tuned. Please, if you haven't subscribed, hit the subscription button so that you will be notified when I drop new video in technical drawing. Thank you very much. God bless you.